question 3. So for part A, we've got to put it in this alternative format with R and alpha. So really themming from cos A minus B formula down here, we can rewrite 4 cos 2 theta minus alpha as this here. So just work your way through that following this. And then we can really equate coefficients. We can say the 4 equates to the 4 cos alpha here, because that's the bit in front of the cos 2 theta, and similarly the r sine alpha is the bit in front of the sin 2 theta. So r cos alpha equals 4 and r sin alpha equals 2. So if we do 2 divided by 1, we get 2 over 4 equaling r sin theta, sin alpha rather, r sin alpha over r cos alpha. The r's cancel and the sin over cos is tan. So 2 divided by 1 gives us tan alpha equals 2 over 4, which is a half. Inverse tanning both sides, we can get alpha being 26.57 to 2 decimal places. So just by considering Pythagoras, then we can say that r squared equals r4 squared plus r2 squared. So r is root 20 or 2 root 5 if you prefer. So that's what r is and that's what alpha is. Now for part B, we've got to solve between minus 90 and 90, this equaling 1. So let's pop it into its alternative format, which we've established here, where we've worked out r is root 20 and alpha is the 26.57. So this is our alternative format. If we then divide through by root 20, we get this, and then I'm going to let capital X equal to 2 theta minus 26.57, and I change my boundaries accordingly. So my revised boundaries for capital X, by doubling these and taking away 26.57, these are my revised boundaries. So given that I've let capital X equal this, I'm now solving cos X equals 1 over root 20. Popping that into my calculator, I get my first solution at 77.1 degrees. Then looking at my cast map, I then get my second solution at minus 77.1 degrees. So then converting these back to get my thetas, I've got to do the opposite process to what I did up here. So I add 26.57 to both and divide by 2. And this gets me back into my original currency, if you like. Gets me back to my thetas being minus 25.3 degrees and 51.8 degrees as my 2 solutions. Now for part C, I want to find the range of possible values of k such that it has no solutions. So again, our starting point is going to be our alternative format here, but rather than this equaling 1, this is going to equal k. So dividing through by root 20, I get this, and then for me to have no solutions, when I cos something and get no solutions, what do I know? I need to be getting 0 solutions above either plus 1 or below minus 1. That would give me no solutions when I cos it. So I have k over root 20 being either greater than 1 or k divided by root 20 being less than minus 1. Multiplying both by root 20, I get k being either greater than root 20 or k being less than minus root 20.